Okay, so what I'm going to do here is I'm going to show you how to make a graph, a standard curve graph using semi-logarithmic scales. Okay, so what I've got here is data that shows the distance traveled in millimeters along the gel. Okay, and the size of the marker band. So, for example, the 23,000 nucleotide band, so the DNA piece that's 23,000 bases long, ran only 11 centimeters in the gel, 11 millimeters in the gel, whereas the 2300 size fragment ran 56 millimeters, and so on. So what I want to do is I want to actually plot this now. So I'm going to just highlight that, and I want a scatter plot, not a line plot. I want a scatter plot. Do it without any lines on it because we're going to add a trend line later. And this is what you end up with. All right. Now, you could work with it like this, but generally speaking, you can kind of see how this is a bit of a curved thing. And you could work with it like this, but what I'd like you to do is change it to a semi-logarithmic scale. So before we do that, the best thing to do is make sure that you add a title and your axis. Now, I'm not going to do this, but you can add a title by clicking on here and then blah, 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 blah. Your axis title, you can add stuff on here. Whoops. And you can click in there and type in, don't forget your units. Okay. And same with down here. Okay. Now, all that aside, what we want is this axis here to be a logarithmic scale. Okay, we can leave this one the way it is. That's why the graph is called a semi-log graph, because only one of the two axes is going to be logarithmic. So to do that, you want to point at the x, the vertical value axis, and if you right-click or double-click on that, you go to Format Axis, and under the scale bar, there's a number of things that you should do. First of all, you want to click this button and change it to logarithmic scale. Now you can see if you kind of take a look at the graph, it's kind of like, well, that's not overly helpful. And it's because you've got all this empty space. So what you want to do is change your minimum and maximum values to align a little bit better with your data. So for example, the maximum value that we need here is probably 30,000, okay, because 23,000 is the biggest, so 30,000 is more than enough. Okay, the minimum, we don't need 1, 10, 100. We can put the minimum at 1,000 since our smallest band is got that, and that's the way it looks now. Now again, this isn't overly helpful because there's all this blank space. So again, if you right-click on this and go under Format, the other thing you should do is add tick marks, the minor tick marks on the outside. And that will give you these little tick marks here. Again, not overly helpful yet until you do this, where you add minor grid lines. Now it starts to look worthwhile, okay? And the way you read this is this line here is 1,000. This line is 10,000, okay, but it's logarithmic, so it's not equal. So this is 1,000, 2,000, 3,000, 4,000, 5, 6, 7, 8, 9, 10. The next one is 20,000. So 10,000, 20,000, 30,000, and it would keep going if we continued. But we don't need that because this is our largest value. Okay, so that's the way it looks. Now, if you want to add a trend line, you point at your data and right-click and add trend line. Now, you can see again, that's not really all that good because it's a linear trend line on a logarithmic scale. So it's tempting to do that, and that's okay, but not really all that great. And don't ask me to explain this because I really don't know, but exponential is the one you're looking for because the relationship between distance traveled and the size of the band is an exponential relationship. If you put an exponential trend line, it ends up being straight. So that looks good. And we've got that all together now. And that is how you make a semi-log graph using your data. And what you can do from here is you can interpolate for the unknown values. So for example, if you had something that was 25, you could read up from here up to the trend line and over and try and estimate the size of the fragment there. I hope that's helpful.